Welcome to the OrientDB Getting Started training on distributed deployment. One area we are extremely proud of our product is in the cluster deployment capabilities. With version 2.0, we introduced new features and a monumental speed increase on distributed functions. The benefits of our multi-master replication can be summarized into three core topics. First, scaling requests. By adding additional nodes to the cluster, you can scale the volume of requests your application can handle. Secondly, replication. Your data is automatically replicated, providing you fault tolerance and high availability. The third is sharding. No longer is your graph limited to one physical disk. These three benefits combined provide you the enterprise-grade deployment options you need. Before we get into configuration options, let's take a look at a distributed deployment in its default state. I have three different machines represented on my desktop. The first black terminal is my local laptop. The other two are Macs on my local network that I'm connected to through screen sharing. I've already downloaded and set up a root password for OrientDB on the desktop of each of these machines. Instead of /server.sh, we'll do dserver.sh, as in distributed server. We'll do this on each of the machines and start up OrientDB on all three machines. What happens at this point is that all three nodes discover each other automatically through the Hazelcast system and start synchronizing the databases. Each of them has the default Grateful Dead concerts database, so they'll be understanding each other and seeing that they're in the same state and ensuring they're synchronized. It's recommended if you have a large database to use the file system to copy over as close to a database as the live system as possible before you add a new node in order to save a lot of network traffic. But either way, OrientDB will take care of the job. So these three nodes are now in sync and understand each other. The first demonstration I can give you is if we take node 3 and go ahead and quit the server. You'll see the other two nodes automatically recognize this fact and start adjusting the cluster to continue working flawlessly. Just as easily as stopping, we can go ahead and do /dserver.sh and we can rejoin the cluster. Each of the three nodes now is aware of each other automatically and seamlessly. Let's go ahead and start working with some data. I'll take my first terminal and make a new tab, and we'll log into the console. So I need to change directory to my desktop, to OrientDB, to the bin folder, and I'll do /console.sh to bring up the console, and we'll do the same thing on each of the three nodes. So a tab here, /console.sh, and on node 3 as well. So let's start on node 3. We'll connect to the Grateful Dead concerts database using the remote channel. Connect remote localhost /Grateful Dead concerts, and we'll connect with the admin user. I'll go ahead and copy this so we can connect with all three without doing a lot of typing. So I'll connect there. I'll go up to the top and connect, and to node 2 and connect. So we have a console working in all three nodes. We'll go to node 2 and we'll insert into V, set, and we'll choose a property, country name equals Canada, and enter that record. And you can see that a record with ID 230 was created. So on node 3 we can select from number 230 and we get that vertex. We can update that vertex, update number 230, set country name equal to France, and go up to node 1, select from number 230. Instantly, those changes are reflected on not only this node, but all three nodes. Select from number 230. We can also delete from number 230. And when we go back up to node 1 and try and select, it's no longer found. So the database on all three of these nodes is seamlessly and automatically updated, a multi-master replication where each node can accept both reads and writes. Just to clarify how robust this setup is, I'm going to go to the server on the first node I started and go ahead and quit that node. You'll see that the other two nodes instantly update in the Java console and work towards creating a unified new cluster deployment and continue to operate seamlessly. Configuration is straightforward. The default distributed deployment settings are described in a JSON file. The first time the database runs, this file is copied into the databases folder and updated when the cluster shape changes. The hazelcast.xml file describes options available for multicast such as group name and cluster password.